Look at this student's answer. The readings look perfect, the handwriting is neat, yet the Cambridge examiner gave it a straight 0. Why? You are sitting in the exam hall. The timer is ticking down. You're looking at a space physics practical question that seems so incredibly easy, yet thousands of 0625 students are about to lose vital, grade boundary shifting marks right here because they treat it like a simple reading exercise instead of a rigorous scientific investigation. Today, we are jumping straight into that exam timer panic. We are going to do a full autopsy on exactly why so many students bleed easy marks on space physics practicals, and more importantly, how you can lock them in.
So, are you losing marks on the simplest data? The Cambridge 0625 exam frequently catches students out on basic data recording mistakes. You might be sitting there thinking that your ordinary revision, just memorizing flashcards and definitions, is enough. Well, spoiler alert, it's absolutely not. Ordinary revision completely fails here because practical questions test your method and your scientific reasoning, not just your memory. If you're dropping marks on something as basic as data collection, we need to fix that right now before you step into that exam hall.
Section 1. The Answer Framework Unlocking Top Band Marks. To secure those maximum marks, you literally have to stop ordinary revision today. Instead, you need to start using the ultimate quick win framework, which we've pulled straight from examiner expectations. Okay, let's dive into the anatomy of a perfect answer. This 4-part formula will literally transform your vague, rambling explanations into precise top-band answers. First, you state the concept clearly. Second, you provide evidence or data directly from your practical results. Third, you add scientific reasoning to connect your data to your concept. And fourth, you wrap the whole thing in precise examiner wording. Now, in just a minute, I'm going to reveal a massive examiner clue hidden right in the layout of your data tables that literally changes your entire answer. But first, you need to see how this framework makes that invisible clue totally obvious. Let's move to a real example. Section 2. Tracking the lunar cycle, the practical setup. Let's apply this 4-step framework directly to our primary source material. We're looking at the classic moon phases experiment. Notice the vital distinction here between the 365-day solar year, which is based on the Earth orbiting the Sun, and the 29.5-day lunar cycle, which is based on the Moon orbiting the Earth. Now, this isn't just fun background trivia. It is the core scientific reasoning for why traditionally, festivals determined by the lunar calendar, like Ramadan, Chinese New Year, and Easter, actually occur on completely different dates every single solar year. You absolutely have to know that 29.5-day figure for your exams.
But listen, before you even touch your apparatus, before you pick up a clock or a compass, you need to define your variables. The phase is explicitly defined as the varying appearance of the moon from Earth. Understanding this key term is the foundational concept for your entire investigation. If you go into the exam and write vague colloquial terms like shape-shifting instead of varying appearance of phases, you are already bleeding marks. Use the scientific terms.
So the crucial point here is how we actually gather our evidence. Notice the specific repetition required in our method, taking readings about every 3 days over a full month. Now, why not every single day? Or why not just twice a month? Well, this interval is absolutely critical for experimental reliability. It gives you just enough data points to map that 29.5-day cycle accurately, without your whole experiment being derailed by a single cloudy night. It's all about reliable data collection. Okay, here is that hidden examiner clue I promised you earlier. Look really closely at how the data is structured in this table. Date, moonrise time, moon set time. If you simply write 9 o'clock in that column without specifying AM or PM, or without using a proper 24-hour format, you instantly fail the evidence check. Examiners explicitly use table headers to see if you actually understand units and precision. Missing units here is a fatal penalty. It's such a silly way to lose marks. Now, what's really fascinating here is a surprising fact that students constantly overlook when they're evaluating their experiments. A full moon is visible only between sunset and sunrise. But the other phases, they can absolutely appear during daylight hours. If your practical method claims that you only looked for the moon at midnight every single night, your scientific reasoning is totally flawed, and I guarantee an examiner will catch that limitation immediately.
Section 3. The Interactive Challenge. Spot the error. Okay, let's step directly into the examiner's shoes for a second. We're going to test your mark scheme awareness and see if you can spot where the points just slip away.
What we have here are the fatal flaws flashing across examiner reports year after year after year. Missing units and rounding too early are, without a doubt, the absolute worst offenders. Think about it.
When you map the 29.5-day cycle on a graph, if you mislabel the axis, or if you round 29.5 up to 30 way before your final calculation, your gradient is ruined, your conclusion is completely thrown off, and the marks are gone. Let's do a quick pause and predict. Think back to our 4-step framework. If your graph is perfectly drawn, your table has all its units, but you still somehow lose the final mark, what did you forget to do in your conclusion? Take a second. What is the single most critical error you can make right at the end?
And here's the answer. The ultimate fatal flaw is writing a conclusion that is not supported by your actual data. You absolutely must explicitly link your final statement back to the specific 29.5 days cycle you just recorded in your table. If you just write a generic fact like, the moon changes, you get exactly 0 marks for reasoning. You haven't proven a single thing with your specific evidence.
Section 4. The autopsy, flawed versus top-band answers. Let's dissect a real scenario using our 4-step framework to see exactly how a top student effortlessly secures the grade and how a rush student completely fumbles it.
This comparison brilliantly illustrates the difference. Listen to this typically flawed answer. The moon changes shape over a month. Yikes! It's vague, it's colloquial, it lacks any real evidence. Now compare that to the top-band answer. Data confirms a 29.5-day repeating cycle of phases, new to full, supporting the duration of the lunar orbit. Boom. It states the concept of phases, it provides the exact substituted 29.5-day data value, it applies proper scientific reasoning about the lunar orbit, and it uses perfect exam-safe wording. That, right there, is exactly how you use the framework. This quote right here, directly from the source material, is your ultimate checklist. Whenever you face a describe or explain command word in a practical investigation, you have to fulfill these criteria. You can permanently eliminate vague explanations by forcing yourself to substitute values with units every single time you make a claim. Data is your best friend.
Oh, and here's one more super quick win for you. When designing a practical investigation, you are very often asked about safety precautions. For the moon phases observation, always just note that this practical presents minimal risk. It's a really simple reasonableness check that examiners absolutely love to see ticked off. Don't overcomplicate it.
Before we wrap up, I want to leave you with a massive real-world anomaly to think about. What if it rains? If clouds obscured your view of the moon for 2 straight weeks, how exactly would you adjust your method to maintain data reliability? Think about how you would handle that using the exact framework we just learned. It's an unresolved problem that requires true mark scheme thinking. If you want to know exactly how examiners penalize you for handling anomalies incorrectly, and if you want to master the time-controlled answer writing system for these exams, that is your mandatory next step. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. The video on your screen right now covers the most brittle examiner report mistakes on anomalies and how to completely avoid them. Click it right now and I will see you over there.